All right, let's take a look at problem number 92, 6-92 on 623. Brielle and Elaine are always travel together to Sunset Beach for their summer vacation. Through the years, they return to the same section of beach and spend their time around the pier. Elaine has noticed that the water rises and falls on the posts of the pier. She thinks the height of the water could be described as a sinusoidal function of time. Brielle was snorkeling and noticed that the pier posts are slimy up to the lowest level of the tide, which was 2 feet for this particular post. Since Brielle and Elaine were on vacation, they had nothing better to do and found out that there was a low point on the post at 8 o'clock in the morning and a high point 40 inches higher at 2 o'clock in the afternoon. Find an equation for the height of the water relative to the post as a function of time from 12 o'clock midnight. All right, let's use the information we got. Let's set up a sketch. Here's time 0 or midnight. And we're working with 1, 2, 3, 4, 5, 6, 7. 8 o'clock something happens. 9, 10, 11, 12, 1, 2 p.m. something happens. All right, so that's our information. Now, I'm going to go for blue for water. The low point was 2 feet for this particular post, and the high was 40 inches higher. So I'm going to call 2 feet 24 inches because that makes sense to me. So there's my low tide. 40 inches higher would be how high? 64. There we go. So what happens? At 8 o'clock, we see a low. At 2 o'clock, we see a high. And we want to find an equation using sine or cosine to model this equation. So we've got a low. We've got a high. Therefore, we've got to have a high somewhere back here. What numbers do we know? What is half of my period? If half of my period is 6 hours, what's my actual period? 12 hours. What is my amplitude? How high up and down do I go total? 40. So my amplitude is half of that, 20. Last thing we need, where's my midline? My horizontal shift, my vertical shift. 20 up from 24 would be 44. And then, are we going to call this a negative cosine graph? A positive cosine graph? Or is there something over here that would make more sense in itself? If half of a period is 6 pi, or 6 hours, can we go back 6 hours to 2 p.m. and assume that there's going to be a high here? This is 12 hours from this. Makes sense to me. So now I've got the beginnings of a positive cosine graph with a horizontal shift of 2. All right, so let's fill it in. Y equals A cosine B x minus h plus k. What do all those letters mean? I've got some good notes for those things. Let's fill them in. All right, I'm going to use my eraser. I know my A. Is 20. I know my K. 44. I know my H. 2. So the only thing left is my B. PB equals 2 pi. My P is 12. So B is pi over 6. Looks good to me. So I have my function that models the height of the water at the pier. Now I can start answering my questions. At 11:30, the girls wanted to take a walk on the beach, but decided to wait until high tide. What was the height of the water at 11:30? Well, it's going to be 8, 9, 10, 11. Here's 11:30, somewhere in here, probably pretty close to the middle. How could I find exactly? I'd put 11:30 in for x, and that's going to tell me my exact value. Then, Brielle's little brother Sean is 2 feet 7 inches tall. Let's sketch him in here. Let's put him in yellow. 2 feet 7 is 31 inches, which is somewhere here. When is the first time after 8 a.m. that the water will be over his head if he plays right next to the post? So we're looking across. Looks like it's going to be, so we need to set our equation equal to 31, add, divide, cosine inverse, do a little math.